A big advantage to this technique, of course, is not only are you keeping your existing information and your proposed information coordinated, you can actually have multiple versions of your proposed data within the same file. But if you actually change the site extent, so if we just do a quick, let's do a simple edit, and let's just move the site boundary by just a random extent, you can see that the data that was apparently deleted, which of course is still there, is exposed instantly. It's an extremely useful tool for manipulating the site extents. If you make errors in your edits, of course, we've got unlimited undo and redo available. So if we just click on undo, in this case we just go back one step, it reverts back to our original arrangement. You can have multiple sets of information open at the same time, either from the same drawing file or project, or from multiple projects if you want to coordinate information across projects, for example. If we look at our window menu, we can see that all of the views that we've been working with are open here, and we can arrange those. Let's just tile those so we can see them on screen simultaneously to see what actions in one window have an effect in another. To show you the effect of editing being consistent across the different views, if I select, for example, the cathedral and delete it, you'll see that that vanishes in all of the views that are open on screens. So, for example, we've lost the red area here now, and the filled area in this one here. And again, I'm just going to undo that, so I can just simply click on the undo button, or the normal undo functions that you've got with Windows. I'm going to close down most of these views now, and we're just going to have a look at the thematic map. The theme data itself is stored as what are called non-graphical attributes. So if we select, for example, let's select one of these objects down here, which is this purple building here, we can see that we've got attached down here some information. Now you've got the Ordnance Survey feature ID, which comes in as part of the import of the master map data, and we've got the building use class here, which is set from a list that we can define, and we can extend this list at any time or edit it, delete whatever elements we want in there, and it's set to industrial. If I change that, for example, to commercial, if you look at the building as I do that, you'll see that the colour immediately updates to reflect the new use class. And again, that's an undoable function. So it's very simple to manipulate the data in this fashion. In this particular case, because the data's internal to the file, we're making the edit directly. If you make the edit in an external database, it will update the drawings automatically as well. Other information that you might attach to elements like this are the value of a property, the ownership of a property, the age of a property, listed building status, all of those kinds of things. Anything that you can conceive of, information can be attached to any object within the drawing that you are working with. As I've already mentioned, we're working on exactly the same set of original data that we imported here. We haven't created any new graphics for this. We're not copying or otherwise manipulating the actual graphics themselves. What we're doing is we're using a technique that MicroGDS calls phasing, and I'm not going to get too deeply into that, but just to illustrate how that works, if I open up the window editor, you can see that what we have here is the layer that contains all of the building information has been replicated as multiple phases. We're not actually duplicating the data, we're just describing the data differently. So for example, we have here on this building layer we're showing the utilities, and on this building layer we're showing the food drink facilities, restaurants, pubs and so on, and then we've got education and so on. So we're actually filtering the information in the same way that you filter information in a database or a spreadsheet. We're actually doing that within the MicroGDS drawing, and that's achievable because of the very powerful object structuring that MicroGDS has always had. You can think of this as being building information modelling in 2 dimensions, for example. Click on Close. We're obviously working with Ordnance Survey master map data here, and if you live in a part of the world where Ordnance Survey data isn't supplied, then you're having to work with a different set of source data. What you can do is you can, if you're working with that data frequently, it would be worth having an import routine built in freely available customization tools. So you could use, for example, the Visual Studio Express tools and the customization tools that are supplied as standard with MicroGDS to create your own import routines. Or you could get Informatics to develop the routine for you, which they would then make available to all of their customers. If they thought there was a demand for it, it would be something that they would consider. Or you can commission one of the consultants that work with MicroGDS to produce the customization for you. I'm going to close this file down now, and I'm going to choose not to save the changes that we've just been doing, and we're going to look at what would happen if you have data that isn't in this structured format, and that's going to be quite a common situation. It's very likely that the data that you're supplied with to act as the basis for your master plan is going to come from a source that doesn't use MicroGDS, and in that case it will probably be drawn in a slightly less structured format. And I've got an example here which is from a real project that I worked on, a real master plan project. So if we click on Open and we just select the raw data file, and if we look at our site plan, first of all, this is the raw site plan data that just brought in as a line drawing. One of the things that very often happens with raw data is that instead of it being created as a series of closed, well-structured data, it's actually drawn very often as a series of individual lines. If I just make sure I've got editable control over my drawing here, our working area drawing, if I just snap onto an element of that site boundary, you'll see that in fact what we've got here is a whole series of separate lines for the site boundary. So what we can do is we can actually use some inbuilt tools that MicroGDS provides to convert that data, and we can do it either en masse globally or selectively, and my personal preference is to always do it selectively because it allows me to retain full control over what's going on. So we'll start off by setting up our site boundary as a properly structured object for MicroGDS use. So I'm just going to switch into the object mode and just select the object that we've got here, and I've made sure that all of the other layers are already set to a non-editable status, and I can then use something here called Spaghetti Trace. Interesting name, but extremely useful in this situation, and it gives me a number of options. It's set by default here to the current selection, which is what I want, and I want to, let's just call this a site boundary so that it's something that I can recognise as a sensible element. Click on OK. Goes away and immediately converts that site boundary to a continuous line that I can now apply a style to. So for example, I can go through my available styles here, and I've already got one here set up as site boundary. So now I've got my continuous site boundary set up. The original data is still there, so I can just choose to delete that if I want, so that we can get rid of that. Let's just make sure that we don't accidentally delete the wrong one. So that's gone, and we've now replaced that data with our site boundary object with a site boundary line style that we've set up in our own style files.